3.0.0 Mechanical Benders. Demonstrate how to use mechanical benders, chart a mechanical bender, and summarize how to make mechanical bends. Conduit bends are normally made in the smaller sizes and weights of conduit and tubing by hand, with the uses of hickeys and other manual bending tools. However, on many projects, mechanical bending equipment with suitable adjustable stops and guides offers many advantages. With proper equipment, any bend can be duplicated quickly and consistently. So here's a mechanical bender. When you're on the job, they'll call this a Chicago bender. This one is being used to bend EMT because they have a follow bar and it supports the bottom of the EMT and keeps it from kinking. You either need that or rollers with big EMT, 1.5 2-inch EMT. You need that follow bar or rollers. So here's the bending shoe, the shoe unit or bending head. Here's the hook that holds the conduit. Here's the conduit. Here's the follow bar. So again, they call that a Chicago. This type of bender is very common among many electrical contractors. To use it, a length of conduit is placed in a position and secured into place. A long bending handle is then pulled around and the bend is completed. These ratchet, so you don't have to just pull it in one motion. You click, 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 click. You just keep ratcheting this and it will coin the bend. That way you're not putting so much physical stress into it. You only have to move the handle short ways. In fact, it says you should not lift the handle above your shoulders, above shoulder height. Don't lift it way up over your head and then bring it down. Lift it over your head. Just bring it like to chest level or shoulders. Portable mechanical conduit bender may be used as a one-shot bender for smaller sizes of conduit. This means the bend's made with one motion bypassing the ratcheting mechanism. The ratchet mechanism, however, is usually activated when bending the larger sizes of conduit to make the work easier. The bender is typically suitable for making bends in conduit sizes up to 2-inch EMT, 1.25 IMC, and 1.5 rigid. Bending shoes and follow bars are designed to form a particular radius bend for a certain type of size conduit, either EMT, IMC, or RMC. And these bending shoes are interchangeable. You take them off and put a different size shoe or for a different type of conduit. EMT has its own shoes. Rigid has its own shoes. These accessories should be treated as precision instruments. Any damage to them will result in inaccurate bends, kinks, other defects. Don't throw them around. Don't throw stuff on top of them. Never use an EMT shoe for bending rigid metal conduit. There you go. This is called a no-dog. They're nice. For information about maintaining bend accuracy, see section 4.1.1. But you can get a no-dog. You can get them online. They're made out of anodized aluminum. They come in different colors. They have a thumb screw that tightens them down to the conduit. And you put them on the side of the conduit and you get this level, especially if you're making an offset. You make the first bend, rotate it 180 degrees, and you again level it, and then you bend the second bend. And it keeps them in the same plane. Following are some general tips to keep in mind when bending with a portable mechanical bender. An engineer's rule marked in hundredths of an inch will simplify bending by eliminating the need to convert to fractions. When minimum length stubs are being bent, the shoe tends to creep and deform the end of the conduit and threads. Screwing a coupling onto the pipe stops the shoe from creeping and protects the threads. That's a highlight. That's a way you can keep the bender from creeping forward and from egg shaping the end of the conduit. Screw a coupling on the end of it. When bending offsets, the front of the bender can be temporarily elevated for clearance requirements. Most bender shoes are made of cast aluminum and are easily pitted and gouged if foreign materials get in between the shoe and the pipe. When the remaining pipe length is too short to reach the roller or pipe support, a larger diameter conduit can be slid over the pipe being bent to complete the bend. If the pipe has threads, screw on a coupling and a short piece of scrap pipe. Segment and concentric bending, the process of making 90-degree bends and parallel runs of conduit, which requires increasing the radius of each successive bend from the first inside bend and working outward. Segment and concentric bending of smaller size pipe can be performed with this bender. Bend a scrap piece of pipe and measure from the center of the bend to the front of the bending shoe. Use this measurement to adjust the start mark using the segment and concentric bending procedures. Okay. And here they're using a protractor to check, make sure that they have the right angle when they're bending. Charting mechanical bender. Benders are typically supplied with charts or decals that indicate the gain and centerline distances for various bends. This is critical data that varies depending on the type of bender in use. If this information is unavailable, the bender can be charted using a scrap piece of conduit. This chart will contain the minimum size, gain, and centerline distance from the arrow on the bender to the center of the bends, 15, 30, 45, and 60. A lot of these benders, they don't have arrows. They're saying from the arrow on the bender. This doesn't have an arrow. What they use is the front of the hook. This is where you take your deduct. If it says the take up is 8.5 inches, they're measuring 8.5 inches to the top of the hook here. Let's see here. So you can come back 10 inches to center and then bend using this as your mark on or the front of the shoe, front of the hook. Then you can bend a 15-degree bend. When you've got the 15-degree bend, find the center of the bend by scoring a line here, scoring a line here. Where those two cross, that's the center of your bend. Place mark on the conduit to give in distance from the end of the conduit. Here the mark will be 10 inches from the end of the conduit. Take a half-inch conduit bender and place the arrow, which represents the take-up or minimum rise of the bender, on the 10-inch mark in front of the end of the bender. Place a protractor level on the conduit in the front of the bender. Bend the 10-inch portion to a 15-degree angle. Remove the bender from the conduit. Take a straight edge and lay it on the inside of the bend so it lies across the bend and rests against the straight portion of the conduit. With a pencil or fine marker, scribe a line across the bend of the conduit. Take the straight edge and lay it across the other side of the conduit. Across the conduits, the straight edge against the side adjacent to the previous position. It should extend across the bend once again. Scribe a line across the bend of the conduit. Two pencil lines should cross to form an X. That's the center of your bend. There's the center of the bend. You can measure from your 10-inch mark and see how many inches back from the end of the hook or the arrow you are to the center of a 15-degree bend. And then you can keep increasing the bend. Make a 22.5, make a 30, make a 45, and each time you write it down. You chart the bender. Okay. Place the bender back into the conduit so that the take-up arrow is on the 10-inch mark. Place the protractor level back on the conduit. Bend the conduit until the protractor level reads 30 degrees. I'd say 22.5 so you can make offsets. Take the bender off the conduit and repeat the line crossing process that was discussed for the 15-degree. Once again, measure from the 10-inch mark and then record your measurement. So you'll have this record of where those bends are. You're charting the bender. And then you can find out what your the back of the conduit or the take-up is. You put it on that 10-inch, and when you're finally done, you bend a 90 and measure from that mark to the ground. And that mark is actually going to be up here somewhere. It'll be about an 8-inch take-up or 8.5-inch take-up for half-inch EMT. All right. And then you can find the gain by measuring these two straight marks. You can put a pipe across here and measure this one, and put a pipe across here, measure this one, you add them together, and you say 1 foot 11 plus 15, that's 26 and 5/8, so that's 2 feet 2 5/8. So we started No, I'm sorry, 3 feet 2 5/8, excuse me. 3 feet 2 5/8. So we have a gain of 2 5/8 inches because we started with a piece that was 3 feet long. So 3 feet 2 5/8, then you subtract the 3 feet original piece of conduit and you find that your gain is 2 5/8 for 190. All right. So they're charting the benders that they can make bends accurately later on. So making mechanical bends, bending stub ups. Following is an example of making a 90-degree stub up in a given length. So you need to know what your take up is, what your deduct is. 15 minus 11 equals 4. Measure the back of the line of each of the conduit by 4" and make a mark. Outline the entire conduit at this point so you'll not lose the mark when the conduit is placed in the bender. Many electricians like to use a black felt tip marker. Don't do that, especially if the pipe's going to be visible after installation. If it's exposed work, don't use any magic markers on your pipe. All right. Bending offsets. A decal chart on the bender that provides deduct information for the stub ups also contains data for making offsets that require 20, 30, and 45-degree bends. This chart is necessary to make perfect offsets every time using the mechanical bender. Assume that you're running a raceway system with half-inch rigid conduit. An air duct must be bypassed, requiring the conduit to be offset. After taking measurements on the job, you find that an offset of 12 inches is needed to clear the air duct. Well, hopefully you can do it on 30 degrees. If not, you can do it on 45, and you multiply that 12 times 1.414, and that'll give you your distance, 16 5/16. Therefore, measure and mark this distance back from the first mark, and then make your two 45-degree bends, and you'll have a 12-inch offset. All right. There they are. They're marking their two marks, and then they'll bend the first 45-degree bend. They'll rotate the pipe 180 degrees using that no dog screwed on one end, and then they'll make their second 45-degree bend. You'll have a 12-inch offset to go over your obstruction. If you're using a bender and the label is worn off, you should chart the bender. You're making a 12-inch stub and 1-inch EMT, and the bender deduct is listed as 8 inches. Where do you make your first mark? 12 minus 8 is 4, so 4 inches from the end of the conduit. All right, very good. Let's go on. 4.0.0, electric and hydraulic benders. Explain how to use electric conduit benders. Explain how to use hydraulic benders. And then you'll have some performance tasks to do in class. It says, always keep following safety guidelines in mind when bending conduit. Read and understand the operating instructions before using any tool. Always use the right tool for the job. Never use bending tools for any other purpose. Watch for pinch points on all bending tools. Use tools in a well-lit, uncluttered area with enough space for the conduit to move about when handling. Be prepared for the unexpected. Make sure all hydraulic connections are clean and tight. Replace any damaged or worn hoses. Make sure tools are complete and properly assembled before operating. Bending shoes and follow bars should be treated as precision instruments. Never toss them into a tool chest or allow them to become damaged or bent out of shape. Electric benders. Electric conduit benders rely on motors, gears, hydraulic pressure, and other mechanical advantages to accomplish this task. There are several types of electric benders on the market. Typical electric unit is shown in figure 22. This is the Greenlee 555. I think I can read it there on the side. This is a Greenlee bender. These are really nice. They have degree marks, so you start the shoe in the 0 degree, and the EMT has to run on these rollers, or rigid has to run on these rollers, and you use the different shoe either for rigid or EMT, and put it in the proper, it's either ½ inch, 3/4, 1 inch, 1.25. Make sure you're in the proper groove. And then you can just bring it up to 90 degrees. Now, we've said this earlier that this conduit is elastic. It's malleable. So you put a piece of pipe in here, you've got your measurements correct, you've got it in the bender correctly, and you bring it up to exactly 90 degrees, and then you release the bender. You've only got about an 87-degree bend. the pipe will spring back. You need to go to about 93 degrees, go over the bend, go past the bend, and then when you release pressure, the pipe will spring back to a perfect 90. And with a little bit of practice, you can hit it every time. So bending charts are often included on the form of decals attached to the bender for a quick reference on the job. These include deduct and spring back, the degree to which a bent section of conduit tends to straighten after pressure is released. For example, a 90-degree bend after pressure is released will spring back about 2 degrees. Many electric benders are sold as power units, and the bending shoes for various types of conduit are sold as accessories. These shoes quickly snap into place on the power unit, ready for use in seconds. So, to describe the operation of the example bender, assume that you need a 16-inch stub up and a piece of 1.25 conduit. Measure and mark a piece of conduit 16 inches from one end. When you check the deduct chart on the bender for this size of conduit, it says 12 3/4 inch deduct. Therefore, 16 minus 12 3/4 is 3 1/4 inches. That's where you should mark it. So therefore, 12 3/4 must be deducted from the 16 inch, which leaves 3 1/4 inches. Then a mark is made at this distance from the end of the conduit. Outline all the way around the conduit so it will be plainly visible during the bend. All right. Insert the conduit into the bender and align the mark with the front of the bending hook. There's no arrow. For this particular bender, the mark is 3 1/4 inch from the end of the conduit. The 3-position operating switch on the example bender is attached to a flexible cord. It has an off center position. It has a forward or bend position and a release or reverse location on the switch. So make sure you're hitting the right one. If you get it exactly perfect, you get it to 93 degrees, and then you want to unload the pipe from the bender and you hit the wrong button, or you just put 5 more degrees in your pipe, now it's overbent. You have to take it out and take some of the bend out. The machine is jogged or inched up until the shoe pointer lines up with the 0 mark in the degree scale. The switch is then pressed upward and held in this position to start the bend. As the pointer approaches the 90-degree mark, refer to the spring back chart for the size and type of conduit being bent. In this case, for 1 1/4 rigid conduit, the chart indicates 95 degrees. Therefore, the pointer should pass the 90-degree mark and stop at the 95-degree mark to allow for spring back when the conduit is removed from the bender. An offset is made in an electric bender similar to the method described in the mechanical bender. That is, the first mark is located on the conduit. Then the offset information is obtained from the bender chart. In this case, a 16-inch offset and a length of 1 1/4 rigid conduit. The chart indicates a distance of 22 5/8 inches between the marks using 45-degree bends. So we'll mark our first mark, and then we'll go 22 5/8 inches and mark the second mark. Mark the conduit and insert it into the bending shoe, positioning the first mark so that it's even with the front of that bender hook. Start the bend as discussed previously until the pointer reaches the 45-degree mark on the scale. Allow for any spring back as indicated on the chart. It's usually about 2 degrees, so go to 47. Reverse the motor until the conduit's loose, then turn the conduit upside down. Rotate it 180 degrees so that you're making the bend in the opposite direction, the second bend. Position the second mark at the front of the bender hook, making certain that the conduit's aligned to prevent a dog leg in the bend. Start the second bend until the pointer reaches the 45-degree mark. Reverse the bender, go to 47 for the spring back, and unload the conduit. A magnetic torpedo level placed on the side of the conduit will help align bends for offsets. An anti-dog device can also be used for this. They're called No Dogs. There's actually a company that makes them. They're really good, so look it up on the internet. No Dog. No Dog, D-O-G. Finally, check the bends for accuracy. Although rebending is possible, it's not a good practice. Rebending puts considerable strain on the conduit. While it may not break, the coating may crack and cause corrosion. All right. Eliminating dog legs, all right. One of the problems that exists when bending an offset or a saddle is the creation of a dog leg. I'm going to highlight this. A dog leg occurs when the center line that runs the length of the conduit is not maintained for both bends of an offset. and for the four bends of a saddle. That's what a dog leg is. They say it's crooked as a dog's hind leg. Dog legs can be eliminated using an anti-dog device or by following the procedure described in this section. If you don't have a no dog, take a piece of unistrut, short piece, 8 inches, 9 inches, and a unistrut strap and tighten it on the pipe. Level it, bend your first bend, rotate it 100 degrees, 180 degrees, and level it again. And then bend the second bend. So here you put your level here and you get a level, you bend your first bend, rotate it 180 degrees to where the unistrut is on top, and you level it a second time and make your second bend. Using a table or plywood to find added length. A table corner or the corner of a sheet of plywood can be used to determine the amount of additional conduit needed to go from one point to another when a bend has been made. For example, suppose the distance between points is 8 feet and the desired offset is 25 inches. The degree of bend is 30. So you've got 8 feet and you've got this 25-inch offset at 30 degrees. We know that this will be 50 inches. It says measure 25 inches up on one side of the sheet of plywood or to the corner of the table. The hypotenuse of the straight line or the triangle will be 50 inches. Choose the cosecant of 30 degrees. Measure from the 25-inch mark to the surface that is tangent to the side that is 25 inches long until the 50-inch mark on the tape measure crosses the tangent side. Mark this 50-inch point. So you take your tape measure from here and you measure down 50 inches until it's tangent, and then you mark it and you draw that. Then place the end of the ruler on the 50-inch mark and let the 50-inch point on the ruler extend beyond the end of the plywood or table. All right. There you go. So here's your 50-inch mark. You take 50 from here and you allow it to extend. They say 50 minus 43 and 3/8 is 6 and 5/8. So when you put this at 43 and 3/8, you find that you've got this perfect 50 inches here, 25 inches here. All right. The amount of tape that extends beyond the plywood or table edge is the amount of extra conduit that's needed to accomplish this bend. This is 6 and 5/8 inches. More conduit than if going in a straight line for 8 feet. So you need 8 feet, 6 and 5/8 inches in order to make that bend. All right. Speed bender. A speed bender operates in basically the same manner as a standard bender, except the speed bender utilizes digital control with easy-to-use bending charts and instructions to ensure fast, accurate, and consistent bends. Basically, you can dial in. It's got a display screen, and you can say, I'm using 1-inch rigid conduit. I need a 12-inch offset on 30 degrees, and you put it in on the first mark and just push the button, and it will bend to 32 degrees and stop. 2 degrees for spring back. You take out the bender, you take out the piece of pipe, and you rotate it 180 degrees, set it up for the second bend, and push the button. You only have to push it once. You just push and let go. And it has an electronic brain. It's a computer. And it'll bring it up to the 32 degrees, bam, and then it'll release, and you'll have a perfect offset every time. You can do the same thing with 90s. You put it in for a 90, and it'll come up to 95 degrees automatically. Hydraulic benders, 4.2.0. The hydraulic bender is indispensable for bending a large conduit, over 2-inch EMT or 1.25 IMC or 1.5 rigid. Only by the addition of the hydraulic pump and cylinder to a bender frame is the necessary power available for bending rigid conduit up to 5-inch trade size. So here is a hydraulic bender. It has a pump, and there's a ram. This is filled with hydraulic fluid. and there's a reservoir over here. So as this pump pumps more fluid in, it causes this ram to extend, and thus it pushes down on this bending shoe and bends the conduit. The bender frame, shoes, follow bar, and saddles will require little more than occasional wiping down to remove dirt and oil film. The pump, cylinder, and hydraulic hoses, however, will demand more attention. The pump should have its fluid level checked periodically. Low fluid pressure will keep the pump from developing its rated hydraulic pressure. When the level is low and the fluid must be added, use only approved hydraulic oil. Ordinary oil will cause damage to the pump assembly. Hydraulic benders have two types of bending shoes, the one-shot shoe and the segment shoe. So the one-shot shoe is 90 degrees and it makes a 90-degree bend in one shot. A larger bending shoe that's designed to make a 90-degree bend in one motion. These segment shoes are about 22.5 degrees. Smaller bending shoe designed specifically for fabricating segmented bends. So you make a little bit of a bend, you move the conduit, make a little bit of a bend, move the conduit. Keep doing that the number of shots, and you'll have a 90-degree at whatever radius you want it to be. The further apart you put your bends, the longer of a radius you'll have in the conduit. So we form around the shoe, a full 90 degrees, being bent without collapsing the walls of the pipe. One-shot benders require no new bending techniques. The take-up is figured in the center of the bend, and the bender shoe will have an indicating mark at its center. If take-up values are not listed on the bender frame or bender storage case, scrap pipe can be bent to find the take-up figures. So, segment shoes are shorter and have a radius that's far less than 90 degrees. 90-degree bend cannot be made in one operation with these shoes, as the conduit walls would collapse. Bends then must be made in several steps, as few as 4 and as many as 30. The segment shoe allows pipe to be bent to larger size radii. That's plural of radius. Segment shoes are often used to create a segmented bend, concentric bends, bending several conduits with increasing or decreasing radii. One-shot shoes can be used for a segment bend, but are not as convenient as segment shoes. So use the segment shoe. Bending rigid aluminum. Rigid aluminum conduit is available in all trade sizes from 1/2 inch through 6 inch. It's lightweight and corrosion resistant, and it has low ground impedance. Rigid aluminum conduit is, however, difficult to bend consistently and accurately. It's very malleable, very soft, so you might bend a 93-degree bend and let go, and you might have a 90-degree bend, or you might have a 93-degree bend. It can get past a point where it just kind of relaxes, and there's little to no spring back in the aluminum. Or you may bend a 93-degree bend, and when you let go of it, it springs back to 90 degrees. Two pipes formed from the same bundle will act differently when bent. Even if two pipes are bent using the same layout, they do not always come out the same. Do not be discouraged by this. This is the nature of the metal. So a little bit of practice, you'll get good at it, and you'll learn how to adjust the bend after you take it out of the bender. It's not going to be perfect, so if you got 89 degrees, you put a coupling on the threads to protect the threads, and you can bounce it on the ground and make it 90 degrees, or you can bounce it on the ground and take some of the bend out of it. If you bounce it in the radius of the 90 without flattening that 90, you can just take a little bit of the bend out. One-shot bending. Accurate one-shot stub-ups are easily made on hydraulic benders by applying a little basic geometry and knowing the operation principles of the bender. Figure 27 shows the reference points of a common 90-degree bend. To make one-shot 90-degree bends, first determine the leg length and rise the gain, the radius of the bend, and the half of gain. So determine the lengths A and B. Add lengths A and B, subtract X from the length of the pipe required, subtract Y from the length A and B to get the center of the bend. So basically, you decide that this is going to be the rise of the pipe, A. And B is the leg length. X is the gain. Y is half the gain. So you're going to take the A plus B minus x. That's the length of conduit required. So you subtract the gain from A and B, and you've got the length of the conduit. And then it says subtract y from the length A or B to get the center of the bend. So here's A, and you would want to subtract y, which is the gain, either from A or from B. Depending on which way you face this in the bender, you'll get a 90. All right. Segmented bends. When bending conduit in segments with a hydraulic bender, the following factors must be determined: the size of the conduit, the radius of the bend, the total number of degrees in the bend, the developed length, and the gain of the bend. So you'll want to find the centers of these one shots. So if you determine 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, they're making 15 shots, I guess at 4 degrees each. So from your developed length, you're going to take 1/2 of the distance of a shot and put a mark, and that's the center of the first shot. Actually, this is over here by the end of the conduit. Here's the center of the first shot. You subtracted half the shot distance, and then from there, you put all of the other shot distances in. And when you get finished, your last shot, number 15, should be half a shot distance away from the end of the developed length. That's how you know you did it right. You must now determine how many bending shots are required to make the bend. An odd number is best, so that there's an equal number of bends on each side of the center mark. So, next, calculate the width of the spaces for each segment. Make the layout of the conduit. An equal number of spaces on each side of the center mark. The gain need only be determined if the bend is being fitted between two existing conduit runs or junction boxes. All right. To determine the bending data for a 90-degree bend using 3-inch conduit with a rise of 48 inches, a leg length of 46 inches, and a center line radius of 30 inches, proceed as follows. So we're going to find the developed length using half of pi times the radius, 30. So we found the developed length of 47.10 inches, or 47 1/8 inch. So we'll have to adjust it. Determine the gain for a 90-degree bend. So you do 0.43 times the radius, which is 30. And oh, they did 2 times 30. What they did was they took 30 and 30, 60 minus the developed length, 47 1/8. They found their gain to be 12 7/8. To calculate the overall length of the conduit, add the leg and stub up lengths and subtract the gain. So 46 and 48 is 94, and then you subtract 12 7/8, and they got 81 1/8. Now locate the center of the required bend. First determine 1/2 of the developed length. So that's 23 1/2. It's close to it, 23 9/16. Use the rise or stub up dimension of 48 inches and subtract the radius 30 inches and add 1/2 of the developed length. There you go. So there's your 48-inch stub height, and then you subtract the 30, and what did they say? You add back the gain, subtract the radius, and add 1/2 the developed length. So the developed length was 47 1/8. So yeah, it's a shame that our developed length is so very close to the stub length. But so again, you subtract the 30, and then you add half of that developed length. That gives you the beginning mark, and then the 47 1/8 inch gives you the end mark. That's your developed length. Generally, 6 degrees or less per bend will produce a good smooth bend for a 30-inch radius. In this case, 6 degrees per bend will be used, making 15 segment bends. 90 divided by 6 equals 15 bends. An odd number of segment bends is easier to lay out because it places an equal number of spaces on each side of the center. All right. So they've laid out their conduit, and they're going to bend each bend to 6 degrees. And I say go 2 degrees over. So the first bend, you don't want to go to 6 degrees, you want to go to 8 degrees. And the second bend, you don't want to go to 12 degrees, you want to go to 14 degrees. So you put your protractor on, you go 8, 14, 20, 26, and you do all 15 shots that way, and you end up with a great smooth bend. Bend to 12 degrees on the second mark and check for spring back. When the first bend of the conduit is moved past the one pipe support, the approximate ram travel of the remaining bends will be the same. All right. I won't do the second example. We had enough hard enough time trying to get through the first example. Bend degree protractor method. So level the conduit and secure it using a pipe vise or other means. Rotate the face of the desired scale that corresponds to the number of shots being used, and adjust the scale so that the pointer is on 0. Bend the pipe until the pointer reaches the first mark. Bend a little past to compensate for spring back. Release the pressure and then check the pointer. Only a few bends will be needed to find out how much you must bend past the mark to account for spring back. With rigid conduit, it's usually 2 degrees. Move the pipe forward in the bender to the second bend mark and bend until the pointer reaches the second mark on the protractor face. Again, compensate for spring back. Move the conduit to the third mark and bend the pipe so that the pointer is at the third mark. Keep going like that until you've done all 15 of them. Magnetic angle finder. With a magnetic angle finder, the pipe must be kept level and bent vertically. The bender's in the vertical position. When a magnetic angle finder is used, you must take care with each bend because a very small error can be magnified 15 to 30 times, resulting in a large error. To use the angle finder, proceed as follows. Level the conduit and place the angle finder on the stub end. Angle finder will indicate the number of degrees in each bend as determined by the number of shots. So again, we're doing 20 shots, it's going to be 4.5 degrees each. Bend the pipe until the angle finder indicates that the bend is just past the desired degree of bend. This allows for spring back. Release hydraulic pressure. If you made the right amount of overbend to allow for spring back, the angle finder should read the desired angle bend. Move the pipe to the second mark, bend this mark until the next setting on the angle finder, allowing for spring back, is indicated by the angle finder pointer. For example, first bend 4.5 degrees, second bend 9 degrees, third bend 13.5 degrees. Amount of travel method. I don't like this one as much because the first 5 or 6 shots you can't rely on the travel method. Set the bender with the pivot shoes in the proper holes for the conduit to be bent. Measure the center-to-center distance between the pivot shoe pins, and then from the center of pin A to the center of pin B. The plunger, also called the ram, will have to travel half this distance to bend a full 90-degree stub. The travel per shot is 1/2 the distance of the pins, pin to pin divided by the number of shots. For example, suppose the distance at the center of the pins is 24 inches and the pipe is being bent in 18 shots. So travel per shot equals 1/2 the distance from center of the pins, 12 inches, divided by the number of shots, 18. This equals 2/3 of a degree, or 2/3 of an inch, or 0.666 inches. Bending with this method will follow a slightly different procedure, which is completed in the following order. Place the center of the bending shoe on the first bending mark and activate the pump until 2/3 of ram travel is measured. Do not allow for spring back with this method. Move the pipe to the next mark and activate the pump until another 2/3 of ram travel has been measured. Continue to move the pipe and measure the ram travel. This is the least accurate approach. I would not suggest trying this until you've been very proficient at bending conduit, and then you can try to play around with the ram travel. Again, the ram travel has to be measured from the point that the shoe makes contact with the conduit. So as you start to bend the conduit, this distance is going to increase with every successive shot. That's why I'm not too crazy about this method. Until you get past the two wheels holding the conduit, then the ram travel will be pretty consistent. But until then, uh, it's not accurate. So it's better to use a protractor. All right. They're saying number of pumps. This is for, takes 40 pumps to bend a 90-degree stub. It should only take 20 pumps to achieve a 45, 10 pumps for a 22.5, 2 pumps for a 4.5. As you can see, this method should work very well, but it'll require additional time to determine pump per degree values. This is in a hydraulic bender that doesn't have an electric ram. You have to pump it by hand. You're actually pumping in order to move the hydraulic fluid. All right. And the same here, if you're doing 30 degrees, you only have to do a third of the pumps. If it was 40 pumps, then you'd do what, 13 pumps, 13, and then flip it over and do another 13 pumps. You'll get a pretty accurate offset, but it may not be accurately 30 inches. You might have to adjust it. All right. All right, I'm not going to read any of this. They're just showing examples of figuring your shots. How many shots per 90? Concentric bends. Here's a highlight. It says if 2 or more parallel runs of conduit must be bent in the same direction, the best results will be obtained by using concentric bends. When laying out concentric bends, the bend for the innermost conduit is calculated first. That's actually another highlight. The bend for the innermost conduit has to be calculated first. First bend has radius of 20 inches. If this dimension is multiplied by 1.57, it yields a value of 31 and 13/32, about 31 and a half inches. 31 and 3/8. That's the developed length of the radius of the innermost pipe segment. And then our start marks will be all the same because they're all going to start at the same point. We're just going to increase the distance between the shots in order to increase the radius of each successive pipe in our concentric bends. So, they're using this as the start mark here. Okay. All right. And here's another highlight. It says the second radius is found by adding the outside diameter size of the first pipe to the radius of the first pipe and the desired spacing between the pipes. So let's say the outside diameter of the first pipe is 2 inches and we want 2 inches between the pipes. We're going to add 4 inches to the radius of the first conduit. They're saying the outside of the first pipe is 2 3/8, the spacing is 2 inches. They're going to add 4 3/8. So the second radius will be 24 3/8. And the third would be 28 3/4. So you just add 4 3/8 each time if you're using the same size conduit. When the developed length of the second radius is found, the spacing between marks can be determined. The start mark must be the same distance from the end of the second pipe as it was for the first pipe. This will be true for each additional pipe as well. So all of the start marks are going to be in the same place on those conduits. That way your couplings will line up. But then we will increase the distance between bends to make these different radii, the radiuses of bends. Radius of the first pipe is 20 inches. The outside of the first pipe is 2 3/8. The spacing between the pipes is 2 inches. Radius of the second pipe is 20 plus 2 3/8 plus 2, so it's 24 3/8. Note the radius change from one bend to another affects the spacing of the segment bends. To find the segment bend spacing, divide the developed length of each bend by 15. For the first bend illustrated, the spacing for each segment bend is 2 3/32. For the second bend, they're 2 9/16. So we had to increase the distance between the bends because we increased the developed length. Each successive developed length needs to be figured at 1.57 times the radius and then divided by 15 to find the spacing between the shots. All right. Offset bends. Here's a highlight. Many situations require a conduit to be bent so that it can pass by or over objects such as beams or to enter a panel board and junction boxes. The bends used for this purpose are called offsets. To produce an offset, two equal bends of less than 90 degrees are required at a specified distance apart. So as we said before, for 30 degrees, the multiplier is 2. Whatever your height of obstruction is, you multiply times 2, and that's the length between the two bends. Okay. Here's their chart on the multipliers. Leave room for system expansion. It's a good idea to make your first concentric bend large enough to fit another bend or two inside it in case you must add additional conduit runs later. Another method is to add any additional conduit runs on the outside of the original bend. Both methods produce a neat professional installation. So here are some nice, I'm not going to say that these are concentric bends. They are all, I think, formed on the same radius bend. All right. Next, multiply the offset height by the multiplier from the chart to determine the distance between the bends. Note that this applies to all sizes of conduit. The chart on figure 38 indicates that to determine unknown length L for 45-degree bends, the multiplier is 1.414. So you multiply the height of the offset by 1.414, and it gives you the distance between bends, 25.5 inches. Let's see here. They seem to be repeating themselves here. All right. I think what they're doing is just giving us a bunch of different examples. So here they're going to bend this offset. And wherever the end of the conduit is, that's the bend you'll make first. Bend it, and then flip it 180 degrees and bend the second one. That'll give you your offset height. So here they've got a 24-inch offset. They're using 45-degree bends. They multiply times 1.414, and they got 33.94 or 34 inches between their bends. 34 inches. They're trying to figure out how much additional conduit they're going to need. So this is going to travel 24 inches, but it's going to do it in 34 inches. So they're actually going to need 10 inches longer of conduit in order to do it. So that's good. 9.95. We're just going to say 10 inches. So add the 9.95 inches to the 8 feet and the amount of straight conduit required that has been determined. Okay. And you can always put your start mark closer to where the obstruction is, and it makes it a lot nicer looking offset to have it close to the obstruction that it's going over. That's just something you want to keep in mind. All right. Let's see here. I think we've hit all of that. Saddle bends. All right. 4.2.6. I'm going to go on to another